Okay, here we go. Let's rock and roll. Let's adjust this. Make sure we're good. Adjusting. Awesome. Okay, this is actually going to be Unit 3, second semester. So it's changed since, the beginning of time. But it's energy. That's what we're covering. We're covering energy transformations. So, for example, potential, kinetic energy, we're going to cover those. And mechanical energy, which seems a little confusing, but it's pretty easy, right? So, first thing you're going to do is we're going to skip over some of it because I'm going to have a separate video, but obviously the first thing you're going to want to do after you look over the cover is to do out the vocabulary, which is write the definition, and, draw an example. I'm going to briefly talk about mechanical energy right now, even though I will cover it in the vocabulary video, just because it confuses people. But mechanical energy, all that is, let's skip over here, all that is you're adding potential and kinetic. That's mechanical, right? Potential plus kinetic, mechanical, very easy, right? So, just as an FYI, because we will, you'll have some questions about that, and I want to make sure you guys know. So, let's jump right in this. So, there's not really a whole lot of messing around. There's links to these sites in Canvas, these sites up here, because sometimes they change from what's in the unit, because this website changes around. So, go for the Canvas, go to those links if you actually need it. But mostly, you're just going to use the formula chart that you have, because this is honestly, it's easy. It took me a long time to make this video because it was so easy. Nobody ever asked a question on it. So I was like, I don't want to make this video in front of the ones that I'm already making because nobody needs help. But eventually, as right now, I'm making the video, so just in case anybody's got any questions. So first things first, let's look at our formulas. Let's look at our formula charts and let's write them on here. So as you can see, we have our kinetic energy formula and we have our potential energy formula, and just kind of mentally note it's gravitational potential energy, right? Because there's different kinds of potential energy. So gravitational potential energy and regular kinetic energy. So we're going to write that on our formula. We're going to write that on our paper. Are we a little blurry? We're a little blurry. Let's de-blur that. All right, so as that's fixing up, let's write our formula. So kinetic energy equals 1/2 times mass times velocity squared, and potential energy equals mass times gravity times height. Keeping in mind, it is the gravity of the Earth, because we're dealing with the Earth, right? Let's get a little closer. Maybe that's it. There we go. All right, that's a little better. A little better. Not the best, but it's a little better. Okay, so with that being said, let's work on these problems. So kinetic energy, potential energy, or both. Okay, I do want to cover this real quick. Forget about guessing. Look at the formula. The only time people get it confused on these questions is when they don't look at the formula. Look at the formula, it's a piece of cake. Well, I'm not sure about kinetic energy. I'm not sure. Every time I get asked that, I'm like, okay, well, let's look at the formula. It's literally every time. Let's look at the formula. What does the formula say? 1/2. Okay, you don't change that. Times mass times the velocity squared. So let's think about that. If something has no mass, if that's 0, then it has no kinetic energy. But more importantly, if it has no velocity, it has no kinetic energy, right? This pen has 0 velocity, which means it doesn't matter what its mass is. It has no kinetic energy. It's not moving, right? If I hold it up higher, it has 0 velocity, assuming I'm holding it like still, right? So it has no kinetic energy, right? So if any of these talk about it's not moving, then kinetic energy is 0. Likewise, potential energy. Mass, gravity, those are going to be constant to the object. We already know this is 9.8. Height. If it has a height, it should have some potential energy. As long as these two aren't 0, right? Which they're not going to be. So if I hold this pen up, it has potential energy. If it's on the ground, it has no potential energy, right? So if it's on the ground, that's 0, which means this has to be 0. So I'm only going to do a few of these. They can have both, right? So if it's moving and it still has height, it has both. All right, so let's just jump into it. We're only going to do a few because they're honestly not very hard, and you can probably figure it out. So number one, if an object is at rest, right there, that tells me velocity is 0, which means it has no kinetic energy because this zeroes out these two, right? 0 squared is still 0. So it certainly does not possess this form of energy. Well, that has to be kinetic. If it's at rest, not moving, it has no velocity, right? Let's do 4. I just picked randomly. The amount is expressed using joules. Okay, so they're both joules. Energy is joules, right? So that's both. Okay, let's do 6. The amount depends on its arbitrary assigned 0 level. Well, that's confusing. Arbitrary assigned 0 level. Okay, so I'm just going to YOLO translate that into its height. Arbitrary assigned 0 level. So if it has a height, if it depends on the height, that's going to be potential. That's super confusing, right? Okay, let's look at number 2. A lot of these guys, it's the same stuff you've done with several other units. Like this is very similar. What we're about to do is very similar to the gravity unit, as long as you're paying attention. So remember what we said. Joules is energy, so this is like both, but it said a car is moving along with 40 joules of energy. So without even me finishing this, I already know if it's moving along that we're talking about kinetic. So I'm going to rewrite this. Kinetic energy equals 1/2 mass velocity squared. And now I know it's moving with 0.4 joules of energy. And so where does that go? Well, it says joules, and then it straight up tells you kinetic energy, so it goes here, right? So it's moving with 0.4 equals 1/2 mass velocity squared. If its speed is doubled, its new kinetic energy will be what? Okay, so we don't need to know what the speed is, but if we double it, there's a 2 in front of the v, right? And we have to square it. So 2 squared is 4, which means we times this by 4. So 0.4 times 4 equals 1.6. So these are all direct relationships. And then keeping in mind, mass is, you do nothing to the mass. If you double the mass, you double this kinetic energy. If you half the mass, you half this kinetic energy. You don't need to know what the mass is. That doesn't matter, right? And likewise, whatever you do to this velocity, first you square the number and then you do it to the kinetic energy, right? So if you double the velocity, you double it, 2 squared, and this is times 4. If you cut the velocity in half, it's 1/2 squared, which is 1/4, which means this is 1/4 as big. So let's do, these are easy. I don't want to do too many, but they're not very hard. Let's just skip to 6. Calculate the kinetic energy. Okay, so write my kinetic energy formula equals 1/2 mass velocity squared. Awesome. Is it on there? Too low. Too low. There we go. All right. It has kinetic energy. Calculate the kinetic energy, so we know we don't have that. And 1/2 mass they give us, 5.2. And it's moving at 2.4 meters per second. But we know we have to square it. Velocity squared. So we're going to do 1/2 times 5.2 times 2.4 squared. I can tell you that 1/2 times 5.2 is 2.6, I believe. So it's going to be 2.6 times 2.4 squared. So you square this and multiply it by this. And it should give you, I would pause, do it, make sure you get this. 14.98. And we know it's energy, so we know it's joules. So that's 98 joules with a J. Pretty easy, pretty straightforward. Guys, it's hard to miss these problems. It honestly is. The formula is very, very short. There's no tricks to it. You don't have to divide. You don't have to move it around. It's just like, it is what it is. So, most of you guys are just going to use this more or less as like a key to check your answers. But it's easy, guys. It really is. All right, so let's do 7. Potential energy. What's my formula for potential energy? Potential energy equals mass times gravity times height. Without even reading this, we know gravity is 9.8, right? So calculate the potential energy, so we don't know it yet, of mass, 5.2, gravity, 9.8. We already know that's meters per second squared. I'm just going to put 9.8. Height is 5.8 meters, so we don't have to convert that. It's just straight up in meters. So it's this times this times this. That is like about as easy as it can get, right? It's just multiplying. Most of you guys have your scientific calculator, so you don't even have to think. So pause it, double check it, whatever. Hopefully you've already done it. 295.57 joules, because it's energy. That's a little point there. Bam. Oh, let's box our answers. If you guys are getting caught up or stuck in any way, do what you normally do on your problems. Write your formula, which we did, and then start writing what we have off to the side. So we know mass equals 5.2. My pen's going out. Height equals 5.8. That's mass. Gravity equals 9.8. There we go. Right? So if you're having any kind of trouble, just make sure you write off your stuff to the side, and that'll kind of help you organize your thoughts, right? All right. Number 8. Calculate the speed. Okay, this one's a little different. It's not very hard. If you guys got to this point in physics, second semester, I mean, honestly, this is easy. So, speed. So, they give us kinetic energy. So we know it's kinetic energy equals 1/2 mass velocity squared. Okay, cool. Easy, right? So they give us kinetic energy, right? We know it's joules. Kinetic energy, that means this is definitely kinetic energy. 26.1 equals, so what's my formula for kinetic energy? 1/2 mass velocity squared. 1/2, don't have to think, that's easy. Mass, kilograms is mass, so 5.2. And they wanted the speed, so that's why we know we don't have velocity, so velocity squared. So first thing we need to do is, let's multiply this times this. 5.2, I think we already did this, and I think it was 2.6. Yeah, I want to say 2.6. So we're going to have 2.6 times velocity squared equals 26.1. So far all we've done is this times this, because we could do that, right? Next thing I want to do, and again, you guys probably already know this, it ain't that tricky. We got to divide this out. We want to get this velocity by itself. So divided by 2.6, goodbye. Divided by 2.6. And let's see, because I don't have a calculator, so I'm going to look at my key. And I should have, so we're here. We got that, there we go. We should have about 10.0385 equals velocity squared. So, now back to our question. Do they want the speed squared, the velocity squared? No, they want the velocity. So at this point, you guys should already know what to do because you've done it a million times. Square root this to get it to be just velocity, and then square root this. So you're going to have velocity equals about 3.17, and then you know it's meters per second because it's a velocity, right? Velocity is in meters per second. Pretty easy, pretty straightforward. I mean, no tricks there. Let's see. Should we do more? Okay, let's see. Let's call this a video, and then I'll do another video for the next page. Awesome. If you guys got any questions, let me know.